This video covers the new calibration tools which are included in BoofCV 0.39. You can now quickly switch between three different camera models: Brown, Universal, and Kannala-Brandt. Kannala-Brandt has recently been added to BoofCV and is the only popular library to support its asymmetric coefficient. Quickly switch between different target types and configure their shape with a live preview. Visualize residuals, found corners, undistorted image, corner order, and corner ID, making it easy to find errors and validate quality by inspection. Use the new under development ECoCheck marker, which enables much better multi-camera calibration, especially under blurred condition and high resolution images. You can now remove bad corners and images easily. Just right-click a corner, then click the remove button. Let's start by looking at the new Monocular calibration application. So what you're seeing here is the application. In the center is the image view, which shows the images that are used to calibrate the camera. And you can switch images by clicking on the right-hand side with their name. And then you can control the visualizations by toggling these flags over here. For example, if you click on order, it'll show you a visualization of the order where the color and the line show you where the calibration points are. You can click on points, which shows you the calibration points themselves, and you can click on numbers, where it shows you a unique ID for each calibration point. You can also undistort the image, which shows you what it looks like after you undistort it. When you undistort it, straight lines should now be straight again. So you can see some slight curvature with and without. Now, errors shows you an exaggeration of the errors. In this case, the calibration is very good, so I have to drastically increase the size of the errors to make them visible. You can also zoom in quite a bit if you want. This is good when you need to validate everything's correct and makes sense. And then another useful thing is to show all. Show these little blue dots, show you where all the calibration points were detected across all the images. Ideally, these points will be spread evenly throughout the entire field of view, which are not in this case. So this is not the best calibration you could get out of this camera. Next, we'll talk about some of the new features. So you can adjust pretty much everything in the GUI now, which you could not before. So you can change the camera model. Brown is working very well in this case, we won't change it, and I'll come back to this later. You can change the target, and then you can also look at the results of the calibration. And then you can look at some statistics. So this tells you the average error across everything, and then the max error across all images, and then you can look at the max error in individual images. So if you have a bad image, this is a good place to start looking. And then also, the errors is a good thing to look at when you're trying to figure out if you have a good calibration or not. Now onto this target view. So BoofCV supports a lot of different target types. ECoCheck is a new one that's being developed right now, and it's in a preliminary stage, but it's designed for multi-camera calibration, and in particular it's designed to work well under motion blur and optical blur, as well as other things. And it's proven to be very robust, and some tests have been done, and I'll probably end up writing a paper on it and have another video describing everything it does. But the current results are very good. It encodes a unique ID and has a checksum and error correction built in. So you can change all these different target types. And then you can also see what it looks like in the preview down below. So you can change everything and you know exactly what it should be. Another useful thing is if you're calibrating the data, you can save a target, which is what you just configured here. And this file already has one. So if a directory has a calibration_target.yaml, what this application will do is it'll load it and automatically change the target to that. So that was done for these examples, but it can also be useful in practice. So just to show you what it looks like, I'll go save it. And then let's open it up. So this is just telling it that it's using pretty much the default with a few tweaks. Now if I tell it to use, let's say ECoCheck, and then let's change a bunch of settings. And then let's save this. Oops, don't want to save in tricks just yet. Okay. Oh, you can see some more information that was saved. Okay, let's go back here. Let's pick a fisheye camera. So this is not going to work very well. These errors are massive. Let's go back down to a more reasonable scale. And you can see these errors are very big. Now, remember before when I understored the image, what it looked like? It does not look that good right now. Straight lines are clearly not straight. And the reason for this is that this fisheye camera has a 185-degree field of view. A brown camera model, which is what we're currently using, can only model up to 180 degrees. And even then at 180, it doesn't do a very good job. But let's try to increase the flexibility of the model. We'll add in tangential distortion and increase the number of radial distortion parameters. And so let's look at these statistics. So right now the max error is 13. After my tweaks, it drops down to 9, but it's still pretty crappy. So let's go change the model to universal. And look at the errors. Yeah, this is a lot better. Now, because fisheye can't be undistorted the same way as a pinhole camera, what this will actually do when you click undistort is render a synthetic pinhole camera. And then you can move it around by clicking on the image and dragging this. And inside of here, what I was talking about before, where straight lines should appear to be straight, and it does a pretty good job of helping you just empirically validate that the calibration was done correctly. It will get a little funky around the outer edges, but this is a way to see how good the calibration was. And then let's look at this all image. So this is doing a better job of getting edges. Not perfect. There could be more over here and over here, but it is doing a better job. Let's just hop around and look at a few of these. So, and then just looking at here, everything, the max error for all these images are less than a pixel. So this is probably good calibration. We have a good spread across the whole image. For the most part, it could be better. And all the errors look pretty reasonable. Now, we can still actually improve this a little bit. So let's look at this max error. So I'm happy with this actually, but let's risk overfitting and increase the number of radial parameters in universal compute, and it dropped down a bit more. Now, in the new version of BoofCV, Kannala-Brandt was added. So this is also a popular fisheye camera model, and unlike all the other popular libraries, BoofCV does support the asymmetric parameters. So this allows you to model more cameras than all the other libraries, which just support symmetric. Took a little bit more work to code up, but it does help some. So let's click this, and the error's about the same. Let's add in some asymmetric terms. And it did get better. Now there is a risk that this is overfit. It's kind of hard to tell from this. It would take some very careful analysis to figure out if it's been overfit or not. But the residuals are lower, and a lot of people naively think if you lower the residual, it is always better. For the most part, you can just keep on increasing the number of parameters, and the results will get better. So you can't really trust that. So we've done this, and let's look at a different target type. Let's go to square, because this doesn't do quite as good of a job. Let's go back to our brown model. Okay. Now in this case, the errors are not as good. A lot of this has to do with the fundamentals of this target. So in chessboard, which I recommend you pretty much always use now, there's symmetry. So here, there's always a little bit of blur around the edges. Now tend to suck it in, and that increases error. And that's just pretty much unavoidable. Especially when the images get blurry, you can just see the errors getting worse and worse. So you should use a target with symmetric shapes like a chessboard pattern. Delatile and some other ones also have the same property and would work well. But let's say you have a bad calibration, and let's just pretend that this point is bad. If you right click it, it'll highlight it in green, very obvious, and then you can go to remove point. If you look at the numbers, we can clearly see it's been removed. Let's remove another one. And you can do this for any of the images. Each time you remove a point, you might want to recalibrate and see if your results change. In this case, because there really are no horrendous errors, let's increase the size of the errors and get rid of some of the clutter. And okay, we can get rid of that point. Oops, well, I removed the image. I was going to show you that next. So you can remove entire images if you just don't like one image. Like it just completely failed, and it's just easier to remove it. But go back here, recompute, and stats are about the same, but there's less data here. There are cases where the automatic algorithm will fail to correctly detect the chessboard pattern. That's particularly prevalent in very extreme fisheye images. But I'm also going through the examples right now, and it pretty much handles all the examples very well. Let's move on to stereo vision next. Oh, wait, before I do that, let's go to like save landmarks. So let's say you like this app, but you want to use a different program to actually do the calibration. You can save the location of the detected landmarks by doing save landmark, and then you need to do a directory, so landmarks. Now we go back to here, landmarks. And landmarks are saved in a very easy to understand CSV format. You might need to remove these comments, but every landmark and the pixel location has been saved. Go back and let's open up the stereo calibration app. This has also been significantly changed, and it takes advantage, and I just recommend to use ECoCheck right now, that calibration target I was talking about before. This enables you to do good stereo calibration. So let's look at all. So this pretty much has a uniform fill. There's a couple occasions you can improve, but it's much better than other examples I showed. And the reason why you want to use ECoCheck is for cases like, I would say really good. Okay, so here's a really good one. So in order to get all the left and right side, you pretty much will have the calibration target way outside the image in one of the views. What you want to be able to do is still detect features inside of that, so you can get good coverage on left and right side. So it's not a complete waste. And then I'll show you something else in a second. So you can see it did a good job and got those, and we have those numbers. Okay, so let's look at the rectified view. So what's going on here? So it's undistorted the image, and we actually can do this a little better. Before I do that, let's look at stats. So look at that max there. Let me increase the number of parameters in rail distortion, and that's going to go down by a lot. So before, the default number of radial distortion parameters was not enough to fully model the camera. Now, before the lens, so these are all good. Let me just actually take another step back. Go back and just notice how fast this is also. So we can see right 14 has a large error. That's going to be on the edge of the image. So errors, you can see it right there. Let me make it even more obvious. Okay, so we shouldn't remove that. That's actually a legitimate target. We can zoom in, and we can verify that's good. So that's clearly in a good location. And it's probably the model's insufficient. So, bam. Go back to 14. And the errors are much smaller. So this is also a good way of how you can iterate quickly. You can go through, tweak these things, compute, and then you can immediately see if the statistics improved or not. Now, what's that red line? So if you rectify the image, the points on the y-axis should be identical. In fact, that's how a lot of stereo vision algorithms work. So it's removed the distortion and then rectify the images. So let's move in and let's show the numbers. So we're going to check out, let's say 44. No, I can't see that. 41. So this one up here. Let's zoom in. So there's 41. And then there's 41. So this red line is pretty much lined up. Like, I actually cannot see the error even when I zoom in a lot. These look perfectly aligned. That point's in about the same place. And just looking at the image features manually, like this looks like really good calibration. So that's another way you can verify it, by looking if the y-axis has been aligned. And this will pretty much work. Let's take a look at that. Yep, that's lined up there. So this is working well, and then you also can right-click on features and remove the point, and then you can also remove images like in the Monocular case. And one thing I didn't mention before is, let's say you have some regret and you think you shouldn't have removed it. You can just click reset and undo all the changes you made. And I believe that is it for now, but oh no, one last thing. let's look at what was before ECoCheck. So here's the calibration target from before, and let's look at all, because you need to have the entire chessboard pattern inside the left and right views. You just can't get the whole field of view. And this runs the problem. So like this is bad calibration right here. See this little bending? That often is a sign that it's not been calibrated properly. And because it has no data out there, it doesn't know what the curvature should be, and it won't fit it. So it's just guessing. And there's not much you can do about that unless they switch to a target like ECoCheck, which allows you to have stuff partially inside and outside. So you no longer have this constraint. So that's it for now, and thanks for watching.